Good morning, everyone. Am I audible? Am I audible, everyone?
Yes, ma'am.
Okay, thank you. I hope my screen is visible. Okay. So today, after last class, we did about your filtration part. So slow sand filter, rapid gravity filters, we have uh, explained. I have explained to you. So today, after filtration, we are going to disinfection or sterilization. Okay. So what happens here is that you have filtered the water, like in the slow sand filter or by using the rapid gravity filters. Okay. So you have filtered the water there, but then also after that filtration also some, like harmful diseases or some harmful bacteria. So that can be again present in the water. Okay, though you have done the filtration part, but then also after filtration, some harmful bacteria, they might be present in the water. So these bacteria, obviously, you have to remove it anyhow for the drinking purpose. You cannot drink that water containing bacteria. Okay, because that will cause you some diseases, harmful diseases. It might cause, some bad impact to your health. So you have to, remove those bacteria. So how will you remove those bacteria after filtration? So you have to do a process called disinfection. Okay, so disinfection, or you can say sterilization, the same process. So you use some disinfectants. Okay, using some disinfectants, you kill the pathogenic bacteria that are present in the water to make it, like potable water or to make it drinkable. So you use some disinfectants to use, and this process it is known as your disinfection or sterilization. Okay, and one now, if I say that you have two bowls of water. In one bowl, you have like in that bowl of water, you have turbidity, or you can say you that is present with color, or you can say it has some like a smell, other okay, all those things it has. And the second bowl of water, it has only one single this bacteria. Okay, only one single harmful organism is there. So between these two bowls of water, if I tell you to choose like which one you will choose for drinking, so what will you say? Okay, so like if this one is containing turbidity or color or smell, and the other one it is containing some harmful organism. Okay, so between these two, the bowl of water that is containing only one single like organism, harmful organism, that will prove to be, like very dangerous. Okay, the presence of turbidities, colors or minerals, it can be like it is not that harmful, but like the presence of one single or harmful organism, it will be causing very much dangerous. It is very much dangerous to your health. And how can it be removed? It can be removed by giving disinfection process. And rather than that also, in case of some emergencies like in armies, okay, where like the whole process of treatment is it's not possible to give in armies. Okay, so what they do there is that the ultimate process is the disinfection process. Okay, after filtration, the disinfection process is done to give water to the armies. Okay, so it is a very fast process. So after giving the disinfection process, you can directly drink the water. It will be drinkable. Okay, so like what is the most common disinfectant that is used worldwide? That is your chlorine. Okay, chlorine, it is the like it is the best, and also you can say it is the most important, or the most ideal disinfectant that is used worldwide. Okay, so that is, it is all about what is disinfection or sterilization is. Okay, now let us come to the process, different methods of disinfection. What are the different minor methods of disinfection? How can you do disinfection process? So number one is your boiling of water. Then you can treatment with excess lime, then treatment with ozone. Okay, then treatment with iodine and bromine, then treatment with UV rays, then potassium permanganate, and the last one is treatment with silver, and it is also known as your electro process. So these seven processes, by using these seven processes, you can do your disinfection process. Okay. So number one is your boiling of water. So this, like the boiling, the bacteria that are present in the water, it can be destroyed. Okay, but everyone knows that if we boil water, the like the harmful bacteria that are present in water, it can be removed. Okay, but here, like by if you boil the water for a long time, only then the bacteria can be removed. Okay, but you can boil only a small amount of water. It is not possible to boil the public water supplies. Okay, so it is an effective method of disinfection, but it is not possible to boil the public water supplies because that is a huge amount of water. Okay, so it can kill the germs, but in this by this process, it is possible that it can kill the germs that are present in the water, but it cannot take care of the possibilities of the future contaminations. Okay, it cannot exactly say you that by like in the future no harmful bacteria will again develop. Okay, so it can only kill the existing bacteria that are present in the water, and therefore like this method, it is not at all used for disinfecting the this public supplies. Okay, next one is your like the treatment with excess lime. So we know that the lime, like it is, we have studied while doing the uh, okay, this one we have not studied yet. Okay, we will come to that. So, but we have studied about hardness and all. So, like to remove the hardness or for doing the softening process, we generally use the lime. Okay, lime treatment we use. So, but also it has been like by researching, it has been found that like if you use some excess of lime, okay, if you add the excess of lime to the water, it can like kill the bacteria. Okay, so here you add, like it's written there, it's if you add 14 to 43 ppm, that is milligram per liter of excess lime, so you can remove the bacterial load by how much? 99.3 to 100% from highly polluted waters. So the range, the how much of excess lime you will be using, the range is 14 to 43 ppm of excess lime, and that can remove the bacterial load by your 99.3 to 100% from the polluted waters. Okay, and then again it's written here that the excess lime, when you will add the excess amount of lime, it will raise the pH of the water. Okay, and if it raise the pH of the water, that means the water, it will be alkaline in nature. Okay, so and when this like the water, it becomes alkaline in nature, so what will happen, this alkalinity, or also you can say the acidity, you can never know what it is. So this will, it will be very, very harmful for the survival of the bacteria. Okay, bacteria cannot survive in more alkaline or more acidic water. So that will again kill the bacteria partially, okay, or it can remove the bacteria completely also. Okay, so when this the raises its pH, okay, so about 9 to about, you can say, 9.5. Okay, it will raise the pH to about 9.5, and then it can kill about 99.9 to 100%. That means you can say it will remove the bacteria completely, almost completely. It removes the bacteria. Okay, so this is about your treatment with excess lime. Okay, so next is your treatment with ozone. Okay, so what is treatment with ozone? What is ozone actually? Ozone, it is a gas. Okay, it is a gas. It has a pungent smell. It has a bad smell, and it is also said to be a very good disinfectant. Okay, to remove the bacteria. And this ozone, it is nothing but it is an allotropic form of, it is a form of oxygen. Okay, it has three, it has three atoms of oxygen. Okay, it has three molecules of oxygen, and when you pass the ozone, okay, if you pass the ozone in a high tension electric current, okay, through under a high electric current that has a very high voltage, okay, and through like in a closed chamber where there is a stream of air passing, in that case, like ozone can be created. Okay, ozone is produced. And what is the chemical reaction that is taking place? This is 3 oxygen, okay, 3 O2. It when you pass through a hundred, like a high electric current and a very high voltage under a closed chamber, so it will give a 2 oxygen molecules. Okay, then again after that, you see here. Okay, so like this ozone, like when you pass it and the oxygen molecule is 2 oxygen molecule is produced, so that is a very unstable process. Okay, and so because of its like instability, this ozone, it will again break down. Okay, it will again break down easily to some normal oxygens, and also one oxygen that is known as your nascent oxygen. Okay, you can see the chemical reaction here, that is O3. It again, ozone, it again readily breaks to oxygen and plus O, that is this O is known as your nascent oxygen. Okay, so this, the nascent oxygen that is produced here, it is said to be a very good disinfecting agent. Okay, and it removes the organic matter as well as the bacteria that is present in the water. Okay, and here, for the ozone, it has some many advantages and disadvantages also. Okay, so this ozone, it is, like already told that it is a very unstable, ozone is unstable. So like it doesn't remains in the water for a long time. Okay, okay, it doesn't remains in the water for a long time, and like by the time you have done the treatment, you have started the treatment with ozone, and by the time it reaches the distribution system, this ozone, it gets removed. Okay, it doesn't remains in the water. Okay, so again, this ozone, it is also, it removes the color, then you can say the taste and odor. Okay, and also it removes the bacteria also, obviously it removes the bacteria. And also, if you use the ozone treatment, the water, it becomes a little bit of tasty, you can say, and also a pleasant for drinking. Okay, then like when you use chlorine, then it becomes a somewhat of a bitter taste is there in the water. So like it is not like that. If you use ozone, the water becomes very pleasant in drinking. Okay, and like it has some disadvantages, or you can say some limitations also. Like this ozone treatment, it is very costly. Okay, it is more costly than the chlorination process. Okay, then also, then this ozone, what it needs for its manufacture, it needs electricity. Okay, So only it can be produced when there is electricity, and when if there is no electricity, you cannot manufacture ozone. Okay. So next, like number three is your no residuals can be maintained because it is highly unstable, and thus its use does not ensure safety against possible future contaminations. Like since it is unstable, so you cannot maintain any residuals there. Okay, and therefore you can say that it doesn't give safety against there is you cannot it cannot say that for future there will be no kind of contaminations will develop in the water. It doesn't say so. Okay, so these are all about your this ozone treatment. And also, yes, this ozone is uh, rather than chlorine, it is not that efficient, I can say. Okay, chlorine is more efficient than your this ozone treatment. Okay, then the next is your treatment with iodine and bromine. So this iodine and bromine, it is also helpful in killing the bacteria that are present in the water. These are also disinfectants, and these are available in the markets in this form of pills. You can say, okay, these are present in the form of pills, and these are you can easily use for the for treating the large scale public supplies. Okay, and what is the quantity of bromine or iodine you have to use? It is 8 milligram per liter. Okay, and you have to give for 5 minutes is sufficient. Okay, for 5 minutes if you treat with bromine and iodine, so you can kill the bacteria that are present in the water. So similarly, next one is your treatment with ultraviolet rays. So everyone knows that ultraviolet rays, we get it from the sunlight. Yes. So it has a wavelength of 1000 to 4000 micro wavelength. Okay. So you can see how much it is having a wavelength. That means it is also harmful. Okay. So this like it how it is done. These are basically found from the sunlight, and these are passed by electric current. Okay, you have some like bulbs. Okay, a quartz bulb is there, and there it is a mercury. Okay, in the quartz bulb there is mercury present, and you pass the sunlight through through these quartz bulbs. Okay, then what will happen? This mercury vapor lamps, it is said to be a good source of the sunlight. Okay, so this UV rays, these are also uh, here it's written that these rays are highly effective in killing this type of bacteria. So obviously it will kill the bacteria. So, and also the water that is, treated with ultraviolet rays, it should have a less turbidity. Okay. So the turbidity should be less, and also the color of the water, it should be low. Okay. And normally it should be, you can say it should be colorless. Okay. So, and the turbidity also, it should not exceed 15 milligram per liter. Okay, it should not exceed 15 milligram per liter. So next one is your treatment with potassium permanganate. Okay, so potassium permanganate, like I think in everyone's house while cleaning the wells and all, we use this potassium permanganate. It is a like popular disinfectant, you can say, for cleaning or disinfecting the well waters. So what we do here is that okay, like besides, in this potassium permanganate, besides it kills the bacteria, but it also like helps in oxidizing the taste, okay, producing organic matter. And after that, it is added in, like in small doses. Okay, like you can say it's a very small dose, 0.05 milligram per liter to 0.10 milligram per liter. Okay, so in such a small dose it is used. then how you use this potassium permanganate for treating the water supplies. You take some small amount of potassium permanganate and you dissolve it in a bucket of water, and then you mix it very well, and then you put it in the well water. Okay, so like when you put the potassium, I mean you add the potassium permanganate to water, then what happens, a pink color it is shown. Okay, so if immediately the pink color of the water it disappears, then you can say that there is organic matter present in the well water, and so again you have to add more quantity of potassium permanganate until like the pink color it stays. Okay, and when you do the potassium permanganate treatment, you should not use the well water for at least, you can say, 48 hours. You should not use the well water. And what is the normal dose of potassium permanganate that you use? It is 1 to 2 milligram per liter with a contact period of 4 to 6 hours. Okay, so then last one, it is your treatment with silver. Okay, it is your treatment with silver, or you can say that it is known as electro-cathodic process. So here what is happening is there, you use the metallic silver ions. Okay, so it is treatment with silver. So you use the metallic silver ions, you pass it into the water. Okay, it has a tube which contains some silver electrodes it has, and it is connected to a DC supply of about 1.5 volts. Okay, so like when you introduce the silver ions, that has a very strong germicidal action. Germicidal action means what? It kills the bacteria very fast. Okay, so it acts as a disinfectant. So what is the dose of silver that you have to use? It is your 0.05 to 0.1 milligram per liter, and the contact period it may also vary from 15 minutes to 3 hours. Okay, so this is your all about your about the methods that like disinfecting methods you can use for removing the bacteria present in water. Now we know that chlorine is the most effective disinfectant that is used. So now we will study about the chlorination process, that is your adding of chlorine to water to remove the bacteria that are present. Okay, so like when this chlorine it is added to water, so what happens is that it will form like the hypochlorite ions will form. Okay, so as soon as the chlorine it is added to water, it will form hypochlorous acid, or you can say hypochlorite ions. So it has some chemical reactions also. You can see these. Okay, this one I'm talking about. Here you see this chlorine, when it is added to water, it is forming HOCl plus HCl. That is your hypochlorous acid. Okay, then again this hypochlorous acid that is formed, it is very unstable in nature, and so it will easily break down to hydrogen ions and hypochlorite ions. Okay, so again this HOCl, it is again it breakdowns to hydrogen ions and OCl, that is your hypochlorite ions. Okay, uh, you remember these equations. Okay, which one is formed first? Okay, just remember this: hypochlorous HOCl is formed first, then your hypochlorite ions will come. Okay, then after that, okay, okay, then you can say that the hypochlorous acid, okay, that is formed, it is, you can say, it is very destructive. Okay, it is very destructive, and it is said that it is like 80 times more effective than the hypochlorite ions. Okay, so the pH value of water during the chlorination process, it is maintained less than 7. Okay, so you see here these equations, the chlorine, okay, when you like put it in the water, it will immediately affect to the ammonia that is present in the water, and it will form chloramines. Okay, you can see this ammonia NH3, that is ammonia plus HOCl, that is your hypochlorous acid. Okay, it will give you monochloramine NH2Cl. Then again this NH2Cl, again if it reacts with the hypochlorous acid, then it will give you dichloramine. Okay, then again this dichloramine, when it again reacts with the this hypochlorous acid, then it will again give you nitrogen trichloramine. So please you this remember these equations. Like small MCQs might come from this reactions. Okay, so just try to remember what is formed at first. That is monochloramine is first formed, then dichloramine, and then your nitrogen trichloramine is formed. Okay, then this monochloramine, it has a pH value over 7.5. Then this dichloramine, it has a range of 5 to 6.5, and nitrogen chloramine, it has a pH range of 4.4. Okay, so next is your okay, what are the various forms in which the chlorine can be applied? So this chlorine, it is generally, you can say it is applied in the different forms. So what are those forms that it is being applied? So number one, it is applied in the form of liquid chlorine, or you can say it is applied in the form of chlorine gas. Okay, to the water, obviously. Then number two is it is in the form of hypochlorites or bleaching powder. Then again in the form of chlorine tablets also you can put it in the water. Then also in the form of chloramines, that is you can mix your ammonia and chlorine together. And then also last one is the in the form of chlorine dioxide. So these are the process by which you can say, by the forms, different forms by which you can add chlorine to the water. Next, we come to the types of chlorination and certain important definitions. So, we have the different types of chlorinations. Okay, what are the different types of chlorinations? Number one is your plain chlorination. Okay, number two is your pre-chlorination, then post-chlorination, double chlorination, breakpoint chlorination, super chlorination, and dechlorination. Okay, so what are these? Actually, depending upon how much chlorine you have added or what is the stage at which it is added. So this results upon these types of, it gives these types of chlorination. Okay, so what is plain chlorination? So this plain chlorination, it is like when the chlorine treatment is given, only the chlorine treatment is given to the water and no other treatment it has been given to the raw water. So in that case it is known as your plain chlorination. Okay, and under your plain chlorination, like what it is done, the raw water, it is fed into the distribution system after you give the chlorine treatment only. Okay, and this chlorination, obviously it will help in removing the bacteria also, organic matters or color and everything from the water. Okay, and this technique, it is used for treating only the clear waters which have turbidities less than 20 to 30 milligram per liter. Okay, and that is obtained from directly from the from the source, that is lakes, you can say deep tubes, reservoirs, all these things it is obtained from. And you know like the used quantity of chlorine required for plain chlorination is about 0.5 milligram per liter or more. So what is the quantity of chlorine that will be that you will be using for plain chlorination? It is 0.5 milligram per liter or more. So plain chlorination is what? Only when you use only the chlorine treatment before, like it is, you give the water into the distribution system. So that is known as your plain chlorination. So next one is your pre-chlorination. Okay. Next one is your pre-chlorination. So what is pre-chlorination? It is the process of applying the chlorine to the water before filtration, or rather before sedimentation, coagulation. So when you do the filtration process or you do the coagulation sedimentation process. So before that, before doing that filtration or sedimentation coagulation process, if you give chlorine treatment to the water, okay, so that is known as your pre-chlorination treatment. Okay, and this treatment, it helps in removing the coagulation. Okay, and so if it removes the coagulation, so what will happen, the load on the filters will obviously be less. So before doing the filtration process or before doing the sedimentation coagulation process, if the water is filtered, so that means the sedimentation tank, the filter loads, it will be less, isn't it? It doesn't have to do so much of work to the water, so the load will be less. So again, it will the chlorine dose. What is the chlorine dose? That is the normal chlorine dose. That is your 5 to 10 milligram per liter. Okay, and this pre-chlorination, it is always followed by post-chlorination. That means if you do pre-chlorination, then you have to do post-chlorination also. Okay, so like if you only do pre-chlorination, then you know that there might not be the uh, safety of water, but if you do post-chlorination also, then you can say that it is, you can say the water is finally safety, you can drink it. Okay, so then comes your post chlorination. So what is post chlorination? So like post chlorination, or it is simply, you can say like chlorination also. It is the standard process of applying chlorine in the end when all other treatments have been completed. So you have done all the treatments, okay? Like you have done your filtration process, coagulation process, screening process, everything you have done. Disinfections also you have done, and at last you are adding the chlorine to the water for its complete safety. So that is known as your post chlorination treatment. Okay, so like when you treat the public supplies, you the post chlorination, it is done after your filtration process, and like before the water it enters the distribution system. Okay, so the dose, what is the dose of chlorine that should be added? It is your 0.1 to 0.2 milligram per liter. And what is the contact period? Contact period is 20 minutes. Okay, so okay, 5 minutes is left. Okay, let me complete the next one. That is your double chlorination. Okay, so what is double chlorination? So here, double, from the name itself, you can say that here the chlorination is done twice. Okay, and what is actually double chlorination? The pre-chlorination and the post-chlorination, it is together known as your double chlorination. When you do both pre-chlorination and post-chlorination, it is known as your double chlorination. And this double chlorination, since it uses the pre-chlorination, okay, so its advantages and these are same as those of your pre-chlorination process. Okay, so let us do up to here today. Next, we will go to breakpoint chlorination, and some small terms are left. After this, we will finish this disinfection part, and we will move to the our next treatment part quickly. Okay. Okay, then you give your attendance in my WhatsApp group. Okay. Okay. Thank you, everyone. You may leave the meeting.